My name is Nur Amira and I will start this presentation with the project overview of our case study. The project is proposed construction of a 3-story banquet hall with 1 semi-basement at Bandar Baru Bani, Selangor. The client is Perbadanan Kemajuan Negeri Selangor, PKNS, while the main contractor is Kapal Jaya. The total contract value is RM26.15 million with a site area of 1.486 acre. The construction period is 104 weeks, starting on 18 July 2023 and expected to be completed on 15 July 2025. This project used the PWD Form 203A contract and the bill of quantity pricing method. It also includes a 5% performance bond and 10% retention money to ensure the contractor completes the work according to the contract. The main purpose of this building is to provide a banquet hall for social events, corporate functions, and community activities. The semi-basement is used as a parking area to improve traffic flow. The main construction material include reinforced concrete, steel reinforcement, formwork, finishes, sanitary fittings, and mechanical, also electrical services.
Moving on to our work breakdown structure or WBS, we've broken the early stages of this project into two primary works packages to ensure a smooth, compliant, and structurally sound start. Our official project commencement on July 18, 2023, beginning with phase 1, which is possession of site and preliminaries. For day 1 was strictly dedicated to formal site possession. Following that, we allocated a 10-day window focused entirely on administrative safeguards, securing critical insurance, executing performance bonds, and obtaining from a superintending officer, which is SO, and approvals to ensure we are 100% legally covered. Once cleared, the team spent 15 days on site mobilization. This involved setting up our temporary site office and routing initial utilities like water and electricity. So the site is fully operational. Finally, we conclude this phase with a 10 days period for site clearing and topsoil stripping, removing all organic matters to prepare the raw earth for structural loading. With this site officially prepped and cleared, we immediately transition into the heavy civil works, which is piling and foundation works. This is where we begin building the literal backbone of the project, broken down into 5 distinct steps. First, we have setting out and surveying, taking 5 days to establish exact grid lines and coordinate boundaries. Position here is non-negotiable. Next is the heaviest lift of these phases. Piling installation, spanning 33 days based on our specific soil conditions. We will be installing a mix of bore and driven piles. Once the piles are in, we spend 6 days on pile testing. We will be performing PDA, which is pile driving analyzer, and static load test to physically verify integrity and load capacity. After the verification, we move to pile head hacking, which takes 11 days. This involves cutting down the pile head to the exact design cut-off level specified by our engineers. Finally, we wrap up this phase with pile cap construction over 16 days. This rebar fabrication, formwork setup, and the final concrete pour to tie the piles together and create the unified stable foundation. Now that the foundations are securely in place, we move into the vertical and sub-phases of the project. This brings us to phase 3, which is sub-basement works, which builds our underground infrastructure over 4 steps. We begin with excavation and shoring, a 16-day process where we remove earth to the required depth while simultaneously installing structural shoring system to hold back the surrounding soil and prevent cave-in. Next, in basement waterproofing, taking 6 days, here we apply a comprehensive waterproofing membrane system to completely protect the underground structure from the groundwater penetration and hydrostatic pressure. Following waterproofing, we move into a main slab and retaining wall casting, which spans 25 days. It is incorporating the heavy concrete basement, floor slab, and the thick perimeter concrete retaining walls designed to receive external soil and water pressure. We conclude our sub-basement works with column and upper slab pouring over 15 days. This step involves casting the vertical concrete columns and the overhead basement slab, which effectively complete and sub-basement enclosure and serve as the ground floor platform for the building above. With the ground floor platform finalized, we rise above ground level and transition into phase 4, which is structural building works. This is where the main skeleton of the building takes shape floor by floor. For the first floor, structural works taking 33 days. This involves setting up the formwork, tying steels, rebar, and pouring concrete to construct the columns, beams, and the overhead slab for our first elevated level. Next, we mirror this process for the second floor structural works over 32 days. We repeat the iterative casting cycle on this next level up, allowing the structural loads to safely transfer down to our cured lower frame. Then we move to the third floor and roof floor and roof frame construction taking 30 days. This complete our vertical concrete skeleton by casting the higher set of structural columns and supporting beams. Finally, we top off the structure with roof, steel trusses and cladding installation, a 27-day process. During this time, we will fabricate and erect the heavy structural steel truss system, followed immediately by installing the roof cladding and weatherproofing layers to completely seal the building from the elements. Once the building is weatherproof, we move indoors for floor finishing installation over 39 days, where we will lay down high durability tiling and specialized wood parquet. Concurrently, we will spend 25 days on the detailed banquet hall ceiling installation, crafting its decorative plaster ceiling. Finally, we wrap up these phases with 32 days of internal and external painting to give the project its finalized polished look. Next, let's look at the mechanical and services phases. This is the nervous system of the building, ensuring everything is safe, efficient, and comfortable for future occupants. We begin behind the scene with first fixed routing and conducts, 58 days hiding the core and many piping and electrical cables within the wall and slabs before the close up. Then we spend 40 days on centralized HVAC installation, integrating the heavy plant machinery and ductwork. Safety and mobility come next to 32 days dedicated to fire protection and elevator system. Once the core system are in, we spend 55 days on terminal devices fitting. This is the installation of everyday items like switches, fixtures, sanitary wares, and the PA system. We close this phase up with 70 days of rigorous testing and commissioning to ensure it complies with regulatory codes. Finally, at the project completion and handover, this is closing stretch of our timeline, focusing heavily on quality assurance and formal delivery. We start with the 22 days joint defect inspection, working with the alongside authorities and the superintending officer to log and fix any final snags. Next is 10 days final site cleaning, a deep clean to clear away all industrial dust and construction debris. From an administrative standpoint, we take 2 days for handover documentation, compilation, gathering all the operation manuals, warranties, and as-built drawings. This is all leads up to our final 1-day milestone, the formal date of completion, marking the legal handover, the successful conclusion of 2-year construction journey.
Next, I will explain the first parts of work program. The project starts with possession of site and preliminaries, where temporary facilities like site office, utilities, and safety measures are prepared. After that, site clearance and topsoil stripping are carried out before starting the piling and foundation works. The project then continues with pile testing, pile cap construction, ground beams, and reinforced concrete works. Next, the sub-basement works are completed, including excavation, basement waterproofing, retaining walls, and the basement slab. These activities provide a strong foundation before the main building structure works begin. Then continue with superstructure phase. This includes the construction of the columns, beams, floor slabs, roof structure, and roof cladding. Once the structure is completed, the project moves to architectural finishes such as brick wall, plastering, door and window, floor finishes, shielding works, and painting. At the same time, the mechanical and electrical services are installed, including the electrical wiring, plumbing, sanitary fittings, and air conditioning system. Finally, the project ends with testing and commissioning, final inspection, site cleaning, and handover to the client. This works program helps ensure that the activity is completed in the correct sequence within the 104 weeks construction period. These activities provide a strong foundation before the main building structure works begin.
Assalamualaikum. My name is Nur Anas Suhaila, and today I will present the cash flow management during the pre-construction stage. Cash flow management is important because it ensures that the contractor has sufficient fund before construction begins. It helps the contractor manage important expenses such as project mobilization, labor, material, equipment, insurance and temporary facility. With proper cash flow management, the contractor can reduce the risk of cash shortage and avoid delay during construction. Before mobilization, the contractor also need to prepare the initial capital for this project. The total initial capital required is 2.26 million, which include the preliminary and the performance bond. These costs are necessary to ensure that the project can start smoothly. Next, I will explain the source of finance for this project. The total contract sum is 26.15 million. To finance this project, the contractor used both internal and external sources of finance. Internal financing contribute 40%, while external financing contribute 60% of the total project cost. The internal source include retained profit, share capital and depreciation provision. These are funds generated within the company. Meanwhile, the external source is a bridging loan from Maybank Islamic Berhad, which provide additional working capital before progress payment are received from the client. This financing structure help ensure that construction activity can continue without financial interruption. Next, I will explain the strategy for managing financial risk before project mobilization. There are several important strategies that the contractor should implement. First, financing should be secured early to ensure sufficient working capital before construction start. Second, a cash flow forecast should be prepared to estimate future cash inflow and outflow. The contractor should also maintain a contingency fund to cover unexpected expenses and monitor project expenditure regularly to avoid overspending. Besides that, managing material price fluctuation and maintaining good communication with financial institutions can help reduce financial risk. This strategy help ensure that the project runs smoothly throughout the construction period.
Assalamualaikum, my name is Nur Fatah Zika. This slide explains the description and scope of the method statement. A method statement ensures that construction work is carried out safely, systematically, and according to the project specification. In this project, it focuses on the construction of the ground floor reinforced concrete slab. The work includes site preparation, installation of the dam-proof membrane or DPM, reinforced facing, formwork installation, concrete casting and curing. The scope also covers the required labor, materials, machinery, quality control and safety measures. Overall, this activity help produce a strong, durable and stable foundation for the building. This slide shows the method statement table for activities number 1 until 7 of the ground floor slab construction. The work begins with excavating the overside trench slab and ground beam to the required level. Next, a 100 mm hardcore bed is placed, level, compacted and covered with fine sand to create a stable base. After that, a 4-stage anti-termite treatment is applied to protect the building from termite attacks. Then, 1.1 to 5 mm heavy duty polythene sheet is installed as the dam-proof membrane or DPM to prevent ground moisture from entering the slab. Finally, a 50 mm thick grade 10 lean concrete blinding is placed to provide a clean, level surface before reinforcement and structural concrete works begin.
Hi, Assalamualaikum. My name is Sofiatun and I will present the slide of method statement table for ground floor slab construction covering activities number 8 until 13. So this table will be prepared based on the project build of quantities. The work begins with fixing the BRC A8 steel fabric reinforcement complete with labs, followed by the installation of some formwork along the slab edges. Next, a 150 mm thick grade 30 reinforced concrete ground floor slab is cast using a mixer truck and concrete pump. After concreting, the slab is compacted and finished using a concrete vibrator and power trowel to achieve the required surface quality. Finally, the concrete is cured to ensure sufficient strength before the formwork is removed, and a final inspection is carried out to confirm that the completed ground floor slab meet the required project specification. Next, I will explain the health, safety and environmental consideration for the construction of this project. The safety The safety requirements were referred from the project BQ under the HSE and preliminary section. To ensure a safe working environment, the site must provide essential safety equipment including first aid kit, fire extinguisher, safety signages, and emergency exit sign. All workers involved in the slab construction are required to wear appropriate PPE such as safety helmet, safety shoes, safety vest, glove, and safety goggles. To ensure a safe construction site, all temporary works, including formwork, must be properly designed, inspected, and certified before use. Adequate traffic management, warning signages, and good housekeeping practice are also implemented to protect both workers and public while maintaining a clean and organized site. In addition, environmental measures such as mosquito prevention, dust control, proper waste disposal, and site welfare facilities are provided to minimize environmental impact and ensure workers' well-being. Finally, all construction activities must comply with the Occupational Safety and Health Act 1994, the Factories and Machinery Act 1967, CIDB safety guidelines, and the approved site safety and health plan to ensure the project is completed safely and in accordance with all relevant regulations.
This slide, I would like to present the discussion and reflection. Through this assignment, we learned that proper planning is initial before construction begin. Preparing the work breakdown structure, work program, method statement, metric, and cash flow management has improve our understanding of project planning and coordination. Although challenges such as rising material price, budget control, and resource management may occur, they can be managed through effective planning and communication. Overall, the assignment has strengthened our knowledge of project management and highlight the importance of financial planning and ensure a successful construction project.